Right. Hello. Nice to meet you. So today I'm going to talk about linkers and loaders and exploits related to them. And let me introduce these two characters. I had a nightmare yesterday because of cold, so I came up with these guys. And Timok, I suppose he knows a lot about computer science and security, and he's a Zindamon. He's a beginner of CS. So yeah. Okay. So,
Press it repeat.
does it?
Click on the screen. Just like tap it.
Okay.
And now you can
So overview. So I'm going to talk about why linkers and loaders now, and basic fundamental overview, basic overview of linkers and loaders, and relevant exploits and hacking demo hopefully. But yeah, due to a technical issue, we couldn't show you hacking demo today. That's my bad. And tell you defenses against these exploits. Okay, so why linkers and loaders? So as a beginner, you might think linkers and loaders are unfamiliar to you. I mean, they sound techy. And did they really matter at first? So yeah, Timok explains about it. So yeah, thanks to linkers and loaders, we can ensure each piece of software fits perfectly and run it. Plus, understanding them helps us spot weakness, security weakness. So yeah, as a beginner, Zindamon, green guy, understands it. Sounds important. And what part is about security? So dive into what is related to security, in linkers and loaders. So before, talk about the very linkers and loaders. Let me show you the high level architecture. So when we run a computer, run a source code, first we need source code, and we need to compile them into assembly file. This one, and the assembly will be compiled. Made into an object files, and these object files and some program libraries will be merged into a single executable file by linker. So to run a computer, to run a program, we need a linker. So linker is so important. And about loaders. So loaders are related to how to run those executables. So executables are consists of mainly three components: header, and data segment, and text segment. And these are just file. So we need to put these segments into a real memory. So this is what loaders do. So put those data segments and text segment into real memory addresses. So what linkers are doing is, as I talk about in this slide, place map each segment into each file segment into one single executable segments. So one object file from one object file to and the other one. So linker has another important feature, that is relocation. So when we write a program like CSG, so this one has input function and main function. So in the main function, this one calls print like this. But how in actual program we run, to call a function, we need an exact memory. But in this file, we don't know where this print function is. It's called in here. And so how do we deal with it? So yeah, let's demo. Okay, so how do we into?
Do like Windows arrows to move it through the screen because my clicker is bad.
Okay, so let's first write like temp csg.c and in sprints its main. So when we compile it, when we compile this CSG file into a object file, so shit. Okay, so yeah, here. So here, although can I go back to here? So in assembly, it is written as prints, but in actual object file, it's just written like 00000. So compiler doesn't have exact location of the memory, but it has memory, the symbol of the function, prints as a metadata. So linker will replace this 000 memory location with the actual print's location. So okay. So but wait. Although linkers plays a nice role, do we still need linkers? Anyone has any idea about this question? Do we need linkers? Okay.
Yes, because we're not going to compile all the code within our program when there's other code already on the machine that's already there, so we can just grab them and we link to them, and we can use them in our program.
That's a nice question. That's a nice answer. Okay. Anyone? Any other answer? So yeah, as he said, with linkers we can be productive, but yeah, we don't have to use it. I mean, if we can write a program in gigantic code or compile every program, as he said, at one time, we don't have to link object files. But yeah, to be productive, yeah, we need linkers. So how can I say? Yeah, linkers are always nice to have, but at the same time, it's necessary. So summary: loaders, put executables onto the memory. Linkers link object files into a single executable. And linkers apply relocations. And rest of linkers features are just nice to have features out of sight. So mystery of .a and .so files. So the green guy is wondering. I mean, he thinks Timok knows everything. He doesn't know everything. He just know what he knows. But anyway, he is glad that the green guy learned a lot. But the green guy came up with another question: .a files and .so files. So have you encountered any errors related to .a files and .so files? And although they're often come up with errors, we rarely be told about .a files or .so files. Are they Rinka related? Yeah. It's yes. So .a files, you know, so before dive into .a files, this is a libc, library of C. So in C library is just a is a set of functions, and each file is corresponding to each function. So everything is written in a single function. Every file are written in a single function, and yeah, libc separates sources for each function, just like in the previous slide. So where are they? So actually, they are in. They are in user lib x86. They're here. So we have a lot of like this kind of A file. So these files actually these files are static libraries, and what we use, with these we don't have to compile like printf functions every time. So let's see what they have inside. For example, A. Okay. Yeah. So this this A file is called archive file, and these archive files are just compressed version of compressed set of object files. So okay, go back to linker extracts necessary symbols automatically from this archive library, and find definable symbols like printf, and extract these files with necessary symbols and add it to the output of a linker. So yeah, actually the how can I say, the function, the feature is really simple. Just extract compressed file from in our computer. So a good point is it's simple to implement and simple to understand. Just put compressed files, and executable is independent. So executables are will contain necessary symbol information in without any dependencies. So yeah, it's it makes programmers happier to run the executable, and no need to link entire object files. So for example, if you don't have static library, we may need to compile libc every time we want to compile we want to link using some of the functions. But with this archive file, you need to link. For example, if you want to use printf function, all you have to link is print.o and its dependent files. So, but there are some bad points. Executables have overlapping parts of code. So for example, when you run multiple processes with that use same functions, and with this static linking, we cannot eliminate redundant parts in memory. So it will result in redundant usage of memory, and also need to relink to update the library. So yeah, if there is a security hole or in a library, and every time we find it, we need to relink every object files. So yeah, that will result in security holes. So there is this is another idea to this static library. It's called shared library. So in shared library, instead of link files before running before runtime, we link it in runtime. So here's a shared library. So we first, loader will first put data segment onto the memory, and text segment of shared library onto text segment, and put executables data segment and text segment into another data segment and text segment, and do relocation in runtime in memory. In memory. So yeah, what is good about this functionality is we don't need to load overlapping code. So yeah, that will reduce memory usage and share physical address on memory. So this also decreases memory usage. And when updating a library, we don't have to update an executable, because these executables are just pointing to a specific library, shared library. So we don't have to upload this executable. That thing is complex to understand. So we need to relocate, or do malicious, multiple, processes in runtime. So the implementation is going to be more complex and overhead. So we need to relocate on memory, and every time we run it, so there is a overhead. So, and also need to install not only executable but also libraries. So you might require some difficulties. And updating a library may result in unexpected behavior. For example, APIs has changed and we cannot use old executable anymore or something like that. So this one also has some bad points, of course. So PLT and GLT is another idea to tackle some of shared libraries bad points. So in shared library, we have some overhead due to relocation or some memory issues in runtime. But with PLT and GLT, we can relax some of the issues. So what is it? So PLT and GLT is another segments in how can I say, in object file in the library and in executable. So yeah, it's like so first when we call a function, when we call a function, previously we needed to calculate something every time, from this segment to like this segment, but yeah. So yeah, by installing this indirect reference, from text segment to PLT and GLT, it tries to resolve the problem. So the GLT and PLT are focused. Collects the PLT is just a reference to GLT, and GLT collects library function addresses. So yeah, the relative address of PLT and GLT is always always constant. So we don't have to do complex calculation every time, just like before. So it reduces a computation cost and make it much efficient. So go to exploits in the wild. So although we linker enabled a lot of good points, there are always people who try to manipulate their vulnerabilities. So let's see what attackers are going to do with these features. So first, dynamic link hijacking. So As I said, shared libraries are loaded in runtime, and in Linux, it's the extension is .so, and macOS dlib, and Windows DLL. So this is a case of Windows. So if we search for DLL via relative path, so they're specified to search from a current directory. So what is bad about this? This is bad because, for example, when a programmer doesn't know the specification, and like some attackers place a malicious DLL in a shared remote server. Then when application is opened, the malicious DLL will be loaded into a memory, and that will steal some secret information. Yeah, when an application opens blah blah blah. So yeah, Windows. Although Microsoft knows this specification for a long time, they because of compatibility problem, they didn't fix it. Recently, not recently, but 2000. Yeah, it's they patched about this. So yeah, how did they overcome this DLL issue? So anyone has any idea to overcome this problem? No one?
Search in absolute from an absolute path.
Yeah, kind of. So it's called safe DLL search mode. So it just changed the order of searching. So from they didn't search from they stopped to search from relative path. That's what they did. So it's very simple. So next thing is NX bypass. So there's a mechanism system called DEP, data execution prevention, and this security feature is blocks certain memory regions from executing code, so, leverages the non-execute bit in modern processors, which flag specific memory pages are non-executable. So with this security feature, you cannot naively use buffer overflow. Okay. So this is it's okay. Yeah. And attackers came up with this technique, so return-oriented programming. So this technique is to find what is called a gadget, specific types of instruction sequence, like this. So with these, by placing these gadgets in return address, and they and chaining these gadgets, they replace arguments using this path. Read to EX register and execute this kind of pop over and over again, and finally execute some function with desired arguments. So with this technique, they came over NX bypass. So yeah, how did they overcome this ROP? Return-oriented programming. Does anyone know the solution, or come up with idea?
Like how the compiler designers and
Security people. Huh?
Yeah, I can't remember how they did that.
Oh, you've got it. ASLR. So they enforce ASLR, address space randomization layout. So it's a mechanism to randomize some addresses. So by randomizing, attackers will find it hard to predict the right memory address to jump to. So yeah, they cannot use easily. So this is most related to linker features, PLT and GLT hijack. So And this is techniques to use PLT and GLT to execute. I mean, jump to function that you want to that you desire to go. And so how do they do? So this first assume PIE, position independent executable, is disabled, which means binary base is visible and arbitrary read is possible. So with this, this is equal to PLT is leaked. So if we can read PLT, then that means we can go to GOT and first overwrite a GOT entry and jump to PLT, and then PLT go allow us to go to a desired overwritten address. So this is really clever, but the idea is so simple. Yeah. So yeah, this is really related to linker, and I wanted to do demo, but yeah, from technical issue I can't today. So how do they overcome this PLT and GOT hijack? So does anyone have any idea to prevent this hijack?
Enable PIE.
That's good. That's good. But another thing, I mean, it's okay. It's okay.
Binary starting.
Binary storing. That's what we did. That's what we did.
I don't know if it's the one that's used, but is it solved?
It was solved. I mean, there are several answers. One thing that's so simple is relocation read only. So people invented relocation read only technique, and this prevents GOT being written from being written. So read only, and we can do jump to any address with this technique. So conclusion. So linkers and loaders are rarely taught in class. Understanding them enables to appreciate some security risks, just like I introduced 3 examples. And actually recently Apple revealed that they created a new static linker. Some programmers are developing new linkers which uses a parallelism paradigm, which is so cool. But I thought I didn't have enough time to introduce them. Probably I have, but anyway. So if you are interested in linkers and loaders, you can check yourself. That's it. Thank you.
Thanks for coming, everyone. If you have any questions, feel free to ask now. If not, fill that out. We're doing our event tomorrow in the lab upstairs with Goldman Sachs. So if you're looking for an internship, this might be an opportunity to network with them, potentially, hopefully. Yeah, thank you again.
What time?
What time? 7 o'clock.
Tomorrow.
It should be in our announcements if you need more details.
You stopped it. There it is.